A 2.00 kilogram mass resting on an inclined plane at an angle of 40 degrees with the horizontal is attached to a hanging mass by means of a frictionless pulley as shown in this figure. The hanging mass takes 1.62 seconds to fall through a distance of 1.52 meters starting from rest. What is the mass if A, the inclined surface is frictionless, and B, if mu, or the coefficient of kinetic friction between these two surfaces, is equal to 0.2. Okay? Now to solve for this, for the mass of this hanging block, we need to find out the acceleration of these two blocks. Okay? To solve for that, we make use of this equation. D is equal to 1/2 a t squared. We are solving for a. So a is equal to 2d divided by t squared. Okay. The d is 1.52 meters, and the time it takes would be 1.62 seconds. Then square. To solve for a, press your calculators, you will get 1.158 meters per second squared. We do not round this off yet because this is not our final answer. Now, to solve for the mass, we have to isolate 2.0 kilograms and come up with a summation of forces acting on the 2.0 kilogram mass. Now this mass here will exert a certain force F, which is equal to the F that you have here. Okay? So getting the sum of forces, since the objects are moving and they are accelerated, they should be equal to m times a. Okay? Now, with respect to this 2.0 kilogram mass, there is no friction, okay, as mentioned in this portion, letter A. So, the forces acting along the x would just be negative Fwx plus the F equal to m times a. Now, the Fwx is taken from this 2.0 kilograms times 9.8 meters per second square. You will get negative 19.6 sine 40 degrees plus F is equal to the mass, which is 2.0 kilograms, times the acceleration that we have here, 1.158 meters per second squared. Solving for F, you will get 14.914 newtons. This is the force because of the weight of this object here. So since this is the weight of the object, we can now look for the mass of that block. So the mass is equal to force divided by the acceleration. Okay. So 14.914 newtons divided by the acceleration due to gravity, which is 9.8 meters per second squared. Solving for m, using your calculators, 14.914 divided by 9.8, you get 1.5218 kilograms. Let us round this off to 3 significant digits. We get 1.52 kilograms. This would be the mass given the situation that this surface is frictionless. Now, but what if the surface has friction, mu is equal to 0.2, And you are to maintain the same acceleration, 1.158 meters per second square. Okay, how do we do that? So this time around, letter B, there is friction. So the sum of forces along the x is still m times a. This time around, you have negative f sub m. Since this block of wood is moving upward, frictional force should move downward towards the left. So negative f sub f minus fwx. This one is always negative. Plus f is equal to ma. So we're solving for this f. Okay. So you have negative 0.2, the given mu, 19.6 newtons, cosine 40. Remember, this is the normal force, minus 19.6 newtons sine 40 plus f is equal to 2.0 kilograms multiplied by the acceleration 1.158. 1.158. Okay. Solving, we get F, which is equal to 17.868 newtons. Then we can now solve for the mass. Mass is equal to 17.868 newtons divided by 9.8 meters per second squared. Solving for m, we get 1.823 kilograms. We round this off to 3 significant digits. We get 1.82 kilograms. This would be the mass of this hanging block.